Good morning, students. Today we are going to discuss a very important topic and also new topic, you can say, from the chapter Mechanical Properties of Fluids. Now, in solid, friction, no? So that frictional force can be compared as a viscosity in liquids or in fluids. Friction is nothing but is your opposing force, no? Here, viscosity or viscous force is also some kind of opposing force, which opposes the motion of the fluid. So let me read out what is this property. The property of a liquid by virtue of which an opposing force comes into play between different layers of liquid whenever there is a relative motion between these layers of the liquid is called viscosity. Let me repeat once again. The property of a liquid by virtue of which an opposing force comes into play between different layers of liquid whenever there is a relative motion between the layers of the liquid is called viscosity. So viscosity arises whenever there is a relative motion between the layers of the liquid. Let me explain by considering this figure. You see the shaded region, the bottom line you can say, is your solid surface you can say, and over the surface liquid is flowing. Now what we'll do, we'll split the liquids in layers. So the layer which is direct contact with the solid surface moves with the velocity v, and the layer which is above that layers is moving with velocity v plus dv. You can ask me why the velocity of the layers above the layer which is moving with velocity v is more than the velocity v. The reason is that you see there is a force between like molecules and there is a force between unlike molecules. The force between like molecule is less compared to the force between unlike molecules. So you see if you consider the layer which we consider here over the surface, then there is a force between the liquid molecules and the solid molecules. These are two unlike molecules, is not it? So you can say some kind of adhesive force is there. Now if you consider the layer just above the layer which is moving with velocity v, then you see that there is a force between like molecules, is not it? So it means as the force is weak between the like molecule, that's why it moves with higher velocity. So as we move up from the fixed surface, definitely the layer velocity also increases. So it means you see there is a relative velocity between the layers. If you consider any two layers that moves over the fixed surface, there is always some relative motion. Relative motion in the sense the velocity of one layer is more than that of the velocity of other layers. You are not supposed to destroy the relative velocity. It means there is always relative velocity between the layers. That shows viscous force is always present in the fluid or in the liquid. I think you have understood. Let me define this one more precisely by considering some numerical values. Numerical values in the sense you consider this layer as your number 1 layer and this layer is your number 2 layer. This layer is moving with velocity v and number 2 layer moves with velocity v plus dv. So there is a force between unlike molecules in the sense molecules of the liquid and the molecules of the solid surface. So it is some kind of adhesive force and the force is strong. That's why the layer 1 has a less velocity which we have defined as v. But if you consider the layer, this one, there is a force between like molecules, is not it? So layer 2 is moving with velocity v plus dv. Okay, and this layer moves with the velocity v and this layer is moving with the velocity v plus dv. So there is always some relative velocity between the layers. It means there is a presence of viscous force. Now experimentally it is found the viscous force or viscous drag F between the layers depends on directly proportional to area of the layers. So the area of the layers is more, then the viscous force will be more. And number 2, directly proportional to the velocity gradient. Velocity gradient in the sense you see if you consider again, this layer is at a distance x and this layer is at a distance x plus dx. So there is a velocity gradient between these two layers, and that velocity gradient is nothing but is here dv dx. Velocity gradient means what? Change in velocity with respect to distance. This layer has a distance x from the fixed surface and this layer has a distance x plus dx. This layer is moving with the velocity v plus dv and this layer is moving with the velocity v. So it means there is a velocity gradient. Velocity gradient means change in velocity with respect to the distance. So as we move up, the velocity increases. So the factor directly proportional to the area of the layers. Area of the layers means if the area is more, then the frictional force is more, is not it in case of solid. So similarly in case of liquid also, and directly proportional to the velocity gradient. Velocity gradient means if the velocity gradient is high, it means velocity gradients can be defined by dv dx. So velocity gradient high means what? Change in velocity is high with respect to the change in distance. So F proportional to capital A is the area and F proportional to dv dx. dv dx is nothing but the velocity gradient, change of velocity with respect to distance. So from 1 and 2, F proportional to A dv dx. So if you want to remove the proportionality sign, then you have to bring one constant. So that constant is your coefficient of viscosity. So F equal to eta A dv dx. And some negative sign we have to assign. Now negative sign define that viscous force is opposite the direction of movement. So it is opposite to the direction of movement. The liquid is flowing from left to right, but the viscous force will be from right to left. So it is opposite to the direction of velocity. Now eta is the coefficient of viscosity and negative line shows that direction of F is opposite to the direction of velocity. Now some more parameter you can define using this expression F equal to minus eta A dv dx. So you see this one, if A equal to 1, dv dx equal to 1, then F equal to minus eta. It means coefficient of viscosity of a liquid is defined as the viscous drag acting per unit area, because A we have considered 1 of the layer having unit velocity gradient. So dv dx is your 1. Under that case you can say F equal to eta. Now CGS unit for coefficient of viscosity is your poise, and MK system the unit is your decapoise. Now regarding dimension, again you have to use this formula F equal to minus eta A dv dx. We are considering the magnitude part, eta equal to F A dv dx. So substitute the F is your MA, M1 L1 T minus 2, A is your L2 and L1 T minus 1, then down is also L1, so L1 goes up T minus 1. So ultimately we are getting M1 L minus 1 T minus 1. So this is the dimension for coefficient of viscosity. Now next topic which we are going to define related with the coefficient of viscosity is your Stokes law. Now what is this one? Let me try to read out. Stokes proved that the viscous drag F acting on a spherical body of radius r moving with velocity v in a fluid of coefficient of viscosity eta is given by F equal to 6 pi eta r v. Now we can prove this expression using dimensional analysis. For that, let me consider F proportional to eta to the power a. Small a we have to define. We don't know how it depends, but we have assigned a constant value a that we have to define. Once we can define, then you can say how F depends on eta. Similarly, F proportional to RB, R is the radius of the spherical body, R to the power b we have to define, and F proportional to V to the power c, V is your velocity and c is the constant which you have to define. So using dimensional analysis, you can write F within the third bracket define the dimension of F, eta to the power a dimension, R to the power b with dimension, V to the power c with dimension. So you substitute the formula for the F eta dimensional formula, M1 L1 T minus 2, that is M1 L1 L minus 1 T minus 1 A, L1 B and L1 T minus 1 C. So you just add the coefficient if it is as it is in product form. MA is there, no M parameter, L is minus A plus B plus C and T is your minus A minus C. Now you have to compare the exponent. So 1 equal to A, 1 equal to minus A plus B plus C and that is your simplify. If you do 1 minus 1 plus b plus c, so 2 equal to b plus c. So minus 2 equal to minus a minus c, minus 2 minus a is your 1, so minus 1 minus c, so minus 1 equal to minus c, so c equal to 1. So if you substitute c value in 2 equal to b plus c, we will get b equal to 1. So we are getting a equal to b equal to c equal to 1. So we can substitute in this equation combining form of 1 to 3. So it comes out to be your f proportional to eta rb. So f equal to k eta rb, where k is dimensionless constant. Numerically, k found out to be your 6 pi. So ultimately f equal to 6 pi eta rv. So please go through this topic. These topics are important, and try to be very sincere in physics class, because it's not an easy task for you. You have to study a lot as you are taking science. I don't think that this seems to be your class 10. Before exam you will study and you will get the marks. It's not like that. So be careful and do concentration if you want to survive in this field. So this is all about. Thank you.